Okay, this is your pre-lab video for your metal slug lab. It is a density lab, and we're going to be using graphical analysis to eventually determine the identity of an unknown metal sample. So the materials that you're going to need, you're going to have 4 metal slugs of known identity, and then you're going to have 1 unknown metal sample that's not going to be of the same size. It's going to be like a little snippet off of a metal rod. And then you're going to have a triple beam balance, you're going to have a ruler, you're going to have a graduated cylinder, and you're going to need some graph paper. So what your known metals are, we have 4 different metals. Metal number 1, if you look, they should have a little 1 written on the slug. The slug is a cylinder shape. So on the end of your metal slugs, you should have, for the copper metal slug, it's number 1. For the low alloy steel metal slug, it should be number 2. The number 3 metal is yellow brass, and the number 4 metal slug is the aluminum slug. Okay. Now, like I said, this is all based on density. So if I look at density, which is mass divided by volume, right? I'm going to have the mass, which hopefully we know we're going to get from the triple beam balance. Okay, and then the volume, you can actually get in one of 2 ways, and I'm going to go ahead and let you figure out how to use the tools that we have. I'll tell you what they are. One of them is a ruler, and the other one is a graduated cylinder. You do not need to use both. You can just use one or the other. Okay? Both of them, in one way, shape, or form, will allow you to determine what the volume is. Now, the volume that I have listed here is cubic centimeters. Okay? So cubic centimeters, that's not how you spell meters. Cubic centimeters. There's a couple abbreviations. One of them is cc. You tend to hear that in like the medical field. You need 10 cc's of this, or you need 20 cc's of that. Another way you can write it is centimeters cubed, which some of you may have written like that before. And it's also important to note that a cubic centimeter is also equal to 1 milliliter. So 1 cubic centimeter and 1 milliliter are actually the same volume. Okay, why we have different units for them? Cubic centimeters tend to be used for solid objects, and liquid objects or liquid samples tend to have milliliters as their volume. But either way, you can get the volume of your metal sample. If you divide them, you should get the density in grams per cubic centimeter. Okay? Now, the known samples, as I mentioned here, okay, we know the densities of copper, the low alloy steel, the yellow brass, and the aluminum. Okay, we know those. There's going to be a link on Google Classroom that's going to give you those densities. You are responsible for looking those up. You should have those before you come into class. Okay. One thing I will mention is on that image that I'm going to post on Classroom, the unit of density is kilogram per cubic meter. Okay. Now, obviously, we're not going to be using that unit in the lab as far as we're not measuring in kilograms and we're not measuring in cubic meters. We're going to be measuring, like I said, in grams per cubic centimeter. But good thing is, all you have to do is take your gram per cubic centimeter value, whatever it happens to be. If you multiply that number by 1,000, then you're going to get the kilograms per cubic meter. Okay. It's just a conversion factor. We'll talk a lot more about conversions later, but for this lab's purpose, we're just going to go ahead and take our calculated unit that we did and then just multiply by 1,000 to get a common unit that is present on the image that you're going to need to use. Okay, that's, like I said, present on Classroom. So what you'll be doing is, now that you have you're going to calculate the densities of all of your metal samples, including your unknown metal sample. Okay, so at this point, you're going to have the calculated densities for your known and unknown metal samples, and you will also have the known metals densities, the actual literature values. Okay. Next thing you're going to do is you're going to construct a graph that's going to compare your calculated values Okay, your calculated densities are actually going to be, I should say actually, but they're going to be on the x-axis, your calculated ones, and then the actual densities, that's the one that you're getting from the image, those are going to be on the y-axis. Okay, and they're both going to be in kilograms per cubic meter. Make sure that your units match up. Okay, so they both graphs, both axes should be in kilograms per cubic meter. Okay, once you have that, once you have your XY scatter plot, right, you will then draw a linear regression line, which is also called a best fit line, right? For those of you who don't know quite how to draw a best fit line, it's pretty simple. You have your plots, and then you put a ruler up and say, okay, well, what line is going to best fit all of these points? That doesn't mean connect the dots. Okay, that means I need one straight line that's going to be my best fit for all of this data. Okay, when you're done with that, okay, so I'm going to go ahead and I'll give my example. Let's say I have, here's my plots, right? Obviously, I'm not going to be connecting the dots, but if I were to take a ruler and go, okay, I just freehand that, obviously, but because I can't put a ruler up on the whiteboard. But I drew a best fit line right there. Okay, remember, this is the calculated densities. These are the actual densities. Okay, and remember, they're both in kilograms per cubic meter. So now that I have my best fit line, which remember, your graph should take up a majority of your, if not majority, if not all of your axes. Okay, now that I have my line, I'm going to use, the point slope form, okay, to determine the slope of your line. Okay, so we have y2 minus y1 equals m times x2 minus x1. Okay, so you're just choosing any 2 points on that line, on the line. Okay, any 2 points on the line. Okay, do not choose this point and that point. They are not on the line. Okay, you need to choose 2 points that are on the line. So I'm going to choose that point right there. I'm going to choose this point right here. Okay, what a lot of people do is they choose the y-intercept. That's fine. Okay, that's still a point on the line. Okay, so choose any 2 points on the line. Okay, and then plug it into this equation, and you're going to get the slope. Once I have the slope, then I can use y equals mx plus b, right? Because now that I have slope, okay, check, and I have my x values, right? Because your x value is your calculated density for your unknown. Check. You have the y-intercept. Just look at your graph. Check. This right here, y, will be the actual density of the unknown. When you have the actual density of the unknown, you then will go back to the image that I posted on Google Classroom and see if, to see which metal best matches up with your actual density. Okay? That's pretty much the whole shebang. Okay, a little longer than I was anticipating, but still 9 minutes. Isn't that bad? Take notes on this. Watch it again. If you have questions, be sure to ask before we start, because we're going to start when there are no more questions. Okay? Or I need to get you guys going. All right? So, by all means, and you can also leave comments for questions as well.